the new Bayesian open source marketing mix model library developed by Google Marketing Science team. So today we're going to dive into how to use it, how to use this framework, Python-based, why it's interesting compared to all the other open source libraries, and understand actually what is the data required for this type of projects and what are the interesting part that we can derive from this and how you can actually implement it. At the end of this video, stay till the end, because at the end, I'm going to share with you the link to access this notebook, which is a plug and play. You don't need the data. We're going to use simulated data in order to use this library and unlock these insights. So if you're ready, let's dive into it. First of all, who am I? I'm Gabriel Franco, CEO and co-founder of Cassandra, the fastest incrementality measurement and optimization tool for non-technical marketers. We help companies to scale up their measurements and their optimization strategies, easy to set up MMM, and easy to set up incrementality tests, and calibrate, and using these to calibrate the attribution. Quick shout out to the sponsor of this video, Cassandra. We allow us to do self-service marketing mix models to build the model and assess the ROIs of each campaign types, assess the impact of any marketing activity in your marketing channels, assess diminishing returns of each channel and what are the effect over time of your spend volumes, and then give you an assessment and a tool to plan your marketing investments at a monthly basis. And it allows you to calibrate the model over time with incrementality tests. So analyze the results, unlocking what is being the incremental output of your incrementality test. And you can use this insight in an ongoing basis to calibrate your MMM, to make it more robust and more accurate into predicting future outcomes. But given that, let's dive in. So Meridian has been developed by Google, and it's been developed with a Bayesian framework. The interesting part about Bayesian models is the ability to input prior knowledge and prior beliefs inside the model. So what it comes out is really similar to what you believe it's actually working. The framework of Meridian has a really easy way to input the priors and the prior knowledge of the MMM that you might have on your marketing effectiveness. And there is an easy way to set it up. It's really few lines of codes. Let's start from data. I've imported the clone of the repository. Let's go inside of the Meridian, go data, and use simulated data. So I want to see the CSV file and how it looks like. This is the data set. This is an example in which we have time, impressions, data, competitor sales, spend data for media, and promotion and context variables. One important thing to highlight, compared to Robin, for example, that uses only spend data in order to train the model, here, the impression data is required in order to build the model. So if you want to start building it, you need impression data of your media channel. Really, really important. Second thing is, you can actually build hierarchical models, really like how you could with Lightweight MMM. But in here, you have an easier user experience to build hierarchical models for multiple geographies inside your distribution channel. Now, given the data and what it's required, let's go into the code. We obviously pip install Meridian, then we clone the repository in order to collect the data, and everything is required. Now we import a certain list of functions and library. First thing first, we input all the variables. One thing that I suggest, guys, is to, if you're using Google Colab, go in here, change runtime type and put V220 TPU, which unlocks greater resources for your training, which are going to be required because Bayesian training a Bayesian model is really, really expensive. Little tip. Let's scroll down. So first thing first, we need to add the chords to column. Chords to columns are all the variables that are going to be input into the model. We need to define what is the time, can be weekly or daily, the geography. I don't think this is a requirement, but I might be wrong. Let's add it for this example. Add control variables. So competitor GQV, populations, KPI is conversion. So what we're actually interested in is actually conversions as an actual variable. Revenue per KPI is revenue per conversion, which gives you technically the average or the value of your conversions. And then we focus on media. So media for Meridian is channel X impression. So we need to import impression. And then there is media spend, then we have organic variables, like if there is a channel X, which is not driven by spend, it needs to be inputted. And on media treatment, promotions. So these are all the variables that might influence your overall sales and influence also your medias. The second thing that we need to do, other than importing this, that we can create algorithms to import them automatically based on the keywords if we want. There is impression, add them into media. If there are spend, add them. We want to map how they're linked, okay? So we want to define channel 1, channel 0, channel 2, channel 3, channel 4, and map them one by one, because it needs to link the impression to the spend and understand what that channel represents in the UI that is going to come out. The main, this is really interesting because it doesn't use, it uses standardized approach in order to import all the requirements of the data inside of this modeling part, this data feature engineering part, which is done inside of the model. Now, given all this is just to map all the variables that we might have. Given this mapping, we import this mapping into a function called load CSV data loader, in which, like in pandas, you add the path of the file, a KPI type, non-revenue. Then we need to just map core to columns, correct media to channels, and correct media spend to channels, which is mapping channel 0 to the spend and impression. I mean, I have a lot of opinions about this, but it's not the worst part. It's not the easiest way of doing things. Overall, fairly easy. Now, here it starts to become really interesting. The interesting part about Meridian is that you can import priors, just giving what you believe the ROI will be. So what we can say is that we can define ROI MU, which could be the mean ROI that we expect from all our media channels. And then we can insert ROI sigma, which represents the standard deviation of that ROI on top of each ROI mean that we expect. So the ROI can move from 0 to 0.2 plus 0.9. So this is the belief that we insert into the model. And it is really interesting. We can expand this, but for this example, I'm going to keep it like this. We define what are the priors, and then we insert the priors inside of this model spec function. So in these model spec functions, we are just importing the prior belief that we set it up here with this prior distribution function here that allows us to automatically insert our beliefs inside of the model. When the model specs are ready, we define MMM as model Meridian, which is a function inside of the model Meridian inside the model, and then there is the class-based Meridian, which we just need to insert the specs of the model and the data. Now, here is another interesting part, MMM sample prior. What we do here is we try to simulate 500 samples just by taking the insights from the priors. So given the priors, let's simulate 500 samples with that prior and see what we can actually see how it will look like. What are the ranges in which we can move on? What are the ranges of expected prediction of the model? There is no function to plot it yet, but I believe that it's an easy thing to do if we want to look and plot the prior predictive. After sampling the sample prior, we need to sample the posterior. So we just need to start a Monte Carlo simulation, which is the analysis run in order to find all the other parameters for the MMM using Markov chain Monte Carlo simulation. And what we do here is we define a plot bar, a progress bar, in which we can see how many simulations are being run, so we can actually measure how much time it takes in order to train it. Using this backend computer engine, it took 38 minutes. It takes some time. In here, we have the insights of what are the parameters that we need to set into sample posterior. Now, we need to define the number of chains. So the number of chains are the number of independent chains used in the Markov chain Monte Carlo simulation. And adapt are the number of initial samples used to tune the sampling algorithm for better performances. You can increase it or decrease it. You can test multiple scenarios, but usually these are the standard ones that work most of the time. Then we have end burning, which is the number of initial steps from each chain that are discarded, that are not used, and then end keep, the number of samples that you want to keep for each iteration after the burning phase. And here there is a little explanation. This represents the posterior distribution of the model parameters that are used for inference. Now, scrolling down, the outputs that comes out are a list of our hat for each variable that it estimated. So in the estimation, the Bayesian framework estimates all these variables. In here, there is a little legend about what each estimation and other parameter represents. Just to simplify it, is estimating the baseline, estimating the diminishing returns other parameters, estimating the add stock other parameters, estimating the beta, the coefficient of each model, and all these parts are listed in here, and you can study it by yourself. But it's really interesting because it gives us a really easy way to understand whether our model approximate to conversions, taking a benchmark of if the R hat is lower than 1.2, we can approximate and we can say almost with confidence that these results are robust, which is a really important part of this process. Obviously, on top of this, you need to add all the model stability, backtesting required in order to ensure that your model is not only robust on training data, but also it's really robust on predicting and forecasting data points that are not being used in the training period. So this is really important. Now, in this case, for example, in this example, we can see that all the outputs all the R hats of the estimates that have been done are lower than 1 point, which is a robust model. We can go forward. Now, one of the greatest thing about Meridian is that it makes it really easy to share the insight. In this case, for example, what we run is an MMM summarizer. We save the summary inside of a content drive, and then we try to transform it into an HTML file that we can actually show. What are the outputs that we can unlock from this analysis? The output that we can unlock from this analysis obviously are the classic, it's really similar to Robin, right? But it's a more flexible and sexy UI, I would say. So every time you see the output are not deterministic. So the expected, the actual, and the baseline. The only deterministic output is the actual, which is the amount of the revenue that we generated over time. And we have the expected, which is expressed with these confidence intervals here, which allow us to understand how much uncertainty there is in the prediction. And then we have the baseline, which is an interesting part of the baseline is that it's not stable. It varies over time. I haven't checked it up about how it's calculated yet, but it's really, really interesting. We assess obviously the R square, the MAPE, the mean absolute percentage error, and this W MAPE is the weighted by the actual revenue. So it's two ways of calculating mean absolute percentage error. Overall, it's really easy to understand. Second thing, waterfall decomposition. We can actually check each insight, and we can save each graph with SVG, PNG, or view the source, or compile it. Everything is really dynamic. It looks like that they wanted to actually share a platform and a UI, which would be easy to interpret and easy to actually use it in a meeting or in a reunion or actual meeting to solve specific problems in your MMM. We scroll down and we see the spend and revenue contribution percentagely with the ROI. Now, one thing about this graph, we can see the spend share and revenue and the contribution share for each channel, and we can see the ROI assessment. Now, these ROI assessment biased because there are no credible intervals in. We're going to see the credible intervals lower. So everything is showed is a simplification of it's happening inside of your MMM, and these insights reflect the prior that we inserted in the model. Okay. One additional thing that they do is they actually assess the amount of revenue that we would generate without marketing activities with the amount of revenues that has been generated just from media. So they aggregate everything in one place to make it easier to be understood. I see a lot of focus on the user experience in here. We have return on investments. Return on investments, these plots are really interesting, and I think I'm going to add them into Cassandra. Here we can see the percentage contribution of each channel with respect of its ROI. This ROI, obviously, is the incremental ROI that we wouldn't generate it, invest in this channel. And based on how wide and big these are, we can actually assess how much was the investment volume. Next to it, we have the comparison of ROI versus marginal ROI. This insight is specifically useful in order to understand whether there are channels in which there is an opportunity of spending more money. For example, in here, we can actually assess the ROI of 0.7667, but the marginal ROI, if I spent €1 more, would be just 0.3, which is the lowest. It doesn't make sense to me to invest more money. Well, this channel has the best marginal ROI with respect of the ROI. So this channel should have more budget allocated. Let's scroll down. Obviously, just to give you context on how to read it, x-axis ROI, y-axis marginal ROI. And marginal ROI demonstrates what would be the ROI if we increase by €1 or $1 the spend volume on that specific channel. Here we are. Now, we have ROI by channel with 90% credible intervals. So in here, we have the ROI and the credible intervals. So with 90% probability, what are the ranges of the ROI, where they could be? And these are incredibly important. Any marketing mix modeling analysis need to show you what are the credible intervals of confidence. Based on how wide these credible intervals are, you can assess the level of uncertainty there is in a specific model. And let's say, for example, this is the widest confidence interval here. We can actually assess which channel we need to test through an incrementality test first. We can set the priorities based on level of uncertainty of each ROI. Now, next to it, there is the KPI, cost per incremental KPI, which is basically the other function. While here is incremental revenue divided by spend, in here is the opposite, which is incremental spend divided by incremental conversion, incremental revenue, which shows you in a really little. This is shown mostly because most of the time you might have biases in setting up the type of output KPI that you model, and the formula differs. So in order to be sure, they added both of the graphs. And obviously, these graphs can be actually downloaded really easily and imported into a presentation. We have response curves. Response curves are really interesting. One thing that makes me question it is the credible intervals here too. I would like to see how the credible intervals move based on the volume of investment, because maybe a certain volume of investment had fewer records and the uncertainty increases. Even with this graph and this current mean spend volume, these graphs are really, really interesting and give you the insights of what could be the response if we increase the marketing investment volume. Now, let's scroll down, because at the end, what we want from any marketing mix model is to actually build a better investment strategy inside our company. We want to use it in order to calibrate our investment decision. One quick thing that I want to mention is that I strongly suggest to calibrate the model and build a model with all the stability assessment, calibrating it with incrementality test before actually implementing the budget allocator and optimization feature inside of any marketing mix model. Because marketing mix models, if built in a robust way, can be really useful, but if they have a lot of uncertainty, they can create damage inside of the company. Be careful. This is a high value, high risk feature that you need to know when to use it and how to use it. In this example, we're just showcasing the MMM of Meridian. So what is the output? So in here, what we have is budget optimizer, and we call this object with optimizer budget optimizer, which is a class inside of our repo, Meridian. And then we use budget optimizer optimize. It uses, I think, the last 4 weeks or the average of each spend of the historical data that we put, and try to simulate different scenarios and distribute those scenarios across each channel. And all this budget across this channel to simulate multiple scenarios and just choose the ones that maximizes revenue. So scrolling down in here, we've ran the optimization scenario, and then we transform these optimization results into an HTML output, which is amazing. I mean, it takes time because it's really heavy computationally. It's really amazing to see the output. So in here, we have non-optimized budget, optimized budget, which is exactly the same, taking all historical data, non-optimized ROI and the optimized ROI. Now, there's no difference in ROI, but there is a 3.5 million increase in total incremental revenue, which is really useful. It's not statistically significant to add a new decimal point. Sadly, they end up at decimals. Scrolling down. Interesting display of insights. Again, everything about Meridian is being deployed in order to make it easier to share the insights to the organization. So this is one of the most important things inside of Meridian. Now, what they here we have the change in optimized budget, in which they suggest how much to lower specific channels and how much to increase specific channel. They have the optimized distribution in a pie plot, in which they're suggesting to increase channel 4 and channel 0 and channel 2 while decreasing channel 3 and channel 1. There is the optimized incremental revenue across channels. In here, specifically interesting for me because it shows you how much the contribution is going to change. The incremental contribution of each channel is going to change if you implement a strategy. And in this case, for example, the non-optimized one, obviously 204 million incremental revenue, But if we reduce the marketing budget in channel 3, which is a huge drop, we're going to get 8.8 million less, almost a million less from channel 1. But if we reallocate this budget into channel 4, channel 0, etc., we're going to increase by 3.5 million the overall. This insight and this graph is really, really sexy, I would say. I think we're going to use it inside of Cassandra at one point. But now, in order to understand this and understand why there are these prescriptions inside of the MMM, we need to understand the diminishing returns curve. So there is an easy way to understand the optimal level, the current level, and the optimal level. So in here with the dot, you have the current level. And in here, you have the optimized spend with the square. So you can see why they're suggesting an increase or a decrease based on these. You can actually calculate the marginal ROI that each drives. In this case, everything can be actually done. It would have been super sexy to receive the marginal ROI that we would receive by reallocating everything. But overall, this is a good output in order to demonstrate your thesis into the budget. Now, this has been the first output and the first tutorial videos about Meridian MMM. We're going to create other videos to understand what are the capabilities of Meridian and MMM in the future weeks. And one additional thing is that we're going to add Meridian inside of our marketing mix modeling software in the next months in order to increase the ability of our customers to run robust models using multiple algorithms. So hopefully this video has been useful, and I look forward to see you in future videos. Thank you.